Hey everyone, thanks for joining the webinar. My name is Michael Paris and I'm an SDE on the AWS App Sync team. And today we're going to talk about how to build applications using AWS App Sync and a new tool out of AWS called AWS Amplify. So what's our agenda for today? First, we're going to talk about who this talk is for and who would get benefit from it. We're then going to go over what AWS App Sync is and how to use it. We're then going to talk about AWS Amplify and what that new tool chain provides. And then we're going to talk about how we can fit it all together and how it helps you build applications. So first, who is this talk for? You might be relevant for this talk if you've said any of the following things: that you want to build a new app or website and you want it to work on every platform. You want to easily leverage AWS from an existing web or mobile app and you don't want to rewrite everything. If you want to learn about new cool development tools like React and GraphQL, cool new CLIs and serverless technologies. And if you want to focus less on ops and configuration and more on your product. So throughout this talk, we're going to talk about all these different things. First, we're going to talk about AWS App Sync. So AWS App Sync is a new service from AWS that was launched at reInvent last year in the late 2017. It's a managed GraphQL gateway that allows you to interact with backend services in your AWS account from web and mobile apps very easily and provides a really nice developer experience for doing so. When you're building on AppSync, there's a few different things you have to do. The first thing is you have to define the shape of your API using the GraphQL schema definition language. After that, you're going to attach data sources that reference other AWS resources in your own customer account. And last, you're going to write resolvers that act like functions that resolve information from GraphQL by pulling information out of your existing data sources. AppSync is also a real-time data broker. This is useful for many web and mobile use cases where you need to stream data from the cloud into your application and potentially to specific devices. Out of the box, AppSync will provide a subscription broker using MQTT over WebSockets that allows you to easily stream information from any data source through an AppSync API and down to connected clients. So this diagram is a basic overview of how AppSync works. As you can see, everything runs in AWS, and then within AppSync, you have your schema, your resolvers, and your data sources. In your own account, you have your own customer data sources like DynamoDB. In this instance, we have a single post table. AppSync uses IAM credentials and assumes a role in order to talk to data sources in your account on the behalf of AppSync and thus on the behalf of your connected client applications. And you can see that here. This is a simplified view, but we'll talk about how this all works later in the talk. So next, I want to introduce a new set of tools called AWS Amplify. AWS Amplify is two main things. First, it's a set of libraries that simplify using AWS from web and mobile applications. And second, it's a CLI that simplifies deploying AWS resources specifically suited for web and mobile applications. When using the libraries and the CLI, there are a number of categories that stretch a range of services in the AWS offering. So categories includes things such as API, auth, storage, analytics, and more. The AWS Amplify libraries also offer platform-specific wrappers for popular frameworks like React, Angular, Ionic, React Native, iOS, and Android, but also include lower-level libraries that can be used across different platforms. And lastly, the AWS Amplify library is specifically focused on solving common real-world use cases that we've discovered from hearing customer feedback that people are actually facing when building web and mobile applications at their own businesses. Next, we have the CLI. The CLI is specifically suited to helping you configure applications, whereas the library is useful allowing you to use your services from within your applications. The CLI is useful helping you to stand up, configure, and redeploy those applications in different environments. In addition, we're going to introduce a new tool called the GraphQL Transform that makes it even easier to deploy applications for web and mobile apps by allowing you to define data models using GraphQL schema definition language and automatically building the backend infrastructure necessary to make that run. So here's an example of how you would use AWS Amplify. First, you'd start a project locally in your file system and you'd run Amplify init. And then after that, you'd use any number of the category commands in order to interact with your infrastructure. So here you can see we're doing a few things. We're going to add first a Cognito user pool in order to be a directory for our own application's users. We're then going to add an S3 bucket that will store files on behalf of our users in our application. And then we're going to add an AppSync API using the Amplify AD API command. Lastly, after we finish configuring all of these services and categories in the Amplify CLI, we'll deploy them to the cloud using Amplify Push, which will deploy through AWS CloudFormation. So now let's talk about the GraphQL Transform. The GraphQL Transform came along with the Amplify CLI and is a new open source offering, open source library that's maintained by AWS. The idea of the GraphQL Transform is to allow application developers to think about their applications in terms of their data model. So if you're imagining building the next popular social media application, you might be thinking to yourself that you have users and you have posts and you have comments, and that there's some explicit relationships between the data, between your posts and your comments and your users and your posts. And behind the scenes, that data might be stored in any number of different systems, whether it's DynamoDB or Elasticsearch or RDS. The GraphQL Transform's goal is to allow you to think about your application in that sense of users and posts and comments, and to hide all of the complicated logic that turns that data model into an infrastructure that enables you to run an API. It's powered by GraphQL directives, and we'll see an example of this later. But the idea is that anybody can go and define a GraphQL transformer that itself defines a single GraphQL directive. In this example, you can see that we come with a couple pre-built transformers such as model and auth, connection, versioned, and searchable. And then whenever you're defining your application, when those directives are found in the input document, certain things happen. And we'll talk about how this works in practice. So first, let's look at some examples. This is an example of the model transformer. This diagram will look familiar, and you can see that on the left, we have a really simple input document, a schema.graphql, that defines a single type post and decorates it with the @model directive. Once this has gone through the Amplify CLI, the stack to the right will be emitted and deployed to AWS. By default, a model is a object type or an entity, a top-level entity in your API that will be stored in a DynamoDB table and that has CRUD operations generated on it for it automatically. You have the ability to customize these, as we'll see later in the documentation, but this is the simplest case for using the transformer. Once you've created an API using the GraphQL Transformer in the Amplify CLI and you have all your CRUD operations, this is an example of how you would create an object, and an example of what you would get back. The query language that you use here is called GraphQL, and this is how AppSync APIs interact with data living in your AWS account. Here's another example of how you'd run an update mutation that would update an object given a particular ID. And you'll see the same for delete. Delete will take an object and remove it from the data source. Remember, these objects are living in your DynamoDB table. And get. You can also get lists and paginate through objects out of the box. By default, all APIs will come with a list query that will return a connection type where you can paginate using a limit and a next token. The next directive we want to talk about is called the auth directive. In this transformer is responsible for protecting objects in your API. In this instance, you can see we have a type post that has the model directive, but also has an auth directive that says allow groups, and the groups that we're going to allow are the admin group. What this does is it will manipulate resolver logic in the AppSync API so that CRUD operations only allow you to interact with the data if the logged in user is a member of the admin group. This is a really common workflow for mobile applications that need an admin user to have permission to go in and investigate data on their customer's behalf. Auth, in addition to doing what we call static group authorization, allows you to do what we call dynamic group authorization. Dynamic group authorization, as opposed to static, is different for every record. So in static group authorization, you might say that a user that isn't in the admin group can create, update, and delete this object. Dynamic group authorization says every object will have an attribute on it that designates what groups are allowed to manipulate it. In the GraphQL transform, adding this authorization rule is as simple as adding this auth directive to the model type. All of the logic that implements the authorization rule is actually automatically generated and placed into the AppSync resolvers on your behalf. The last authorization scheme that we're going to talk about is ownership authorization. Ownership authorization is similar to dynamic group authorization, but instead of authorizing against a group, it will authorize against the actual user's credential. This is common for example type post, where you want the owner of the post to be able to update and delete it, but anybody would be able to read it. This is what you would use to do so. You can also combine authorization rules. In this example, we have an owner's attribute and a group's attribute where all admin users can create, update, delete, read, and list type post, but also you can create, update, delete, and list type post if you are the owner or if you are any owner in this editor's array. So this is multi-ownership auth combined with static group authorization, such that any one of a set of editors can update this post, and any admin user can update this post. The next transformer we'll talk about is the connection transformer. The connection transformer allows you to create explicit relationships between data and an API. This is common and allows you to do really neat things that you'd normally associate with a SQL database, but you can do it on top of NoSQL using AppSync. So here in this example, we have type post, which is a model, and we have type comment, which is also a model. A post can have multiple comments, and a comment would point back to its parent post. In order to implement this, all we have to do is add the @connection transformer, or the directive, and give it a name, post comments. Since we're providing it a name, it allows us to create a bidirectional relationship between two object entities, in this case, post and comments. This gets emitted as a set of new resolvers in the AppSync API on the post and comment types that point to the comment and post types tables respectively. In this instance, the comment.post field will resolve the single post object that is the parent of this comment, and the post.comments field will resolve from the comments table all of the comments relevant to that post. Here's an example of how you would query with that connection. In this example, you can see that at the top level, we're doing a get post query where we're going to fetch a single post by ID. This is implemented as a get item operation in DynamoDB. That'll return the full object, including the ID and the title. And then next, what we're going to do is we're going to resolve the comments for that post using the post.comments resolver. This is another common practice in GraphQL where you'll create relationships between the objects and you'll use an attribute on the parent object to fulfill the resolver of the sub-objects. In this instance, the comments that are referring to a post are fetched from a GSI on the comment table for all comment records where the post ID is equal to the parent post's ID. We'll see how this is implemented in practice in the AppSync console, but this is an important concept to understand. So now we're going to start talking about how it all fits together. So that was the GraphQL transform that we just talked about, and we talked about how AWS AppSync is the technology that allows us to fetch data from our services, but now we're going to talk about how AWS Amplify fits in to make this really easy to use. So here we already saw that there's an Amplify AD API command. When you run this, and as we'll see later, this will accept a schema document that will be written in GraphQL SDL that will then be spat out as the full CloudFormation spec that implements our data model. After we define the schema using GraphQL SDL, we're going to call Amplify Push, which is going to deploy the CloudFormation document to AWS and launch the API for our application. As soon as we run API Push, we're going to have this fresh API in our AWS account that'll implement our data model that we can use from our web and mobile application. But what about the library? So we talked about how Amplify is two things. There's the library that makes it easy to consume AWS resources from your application, and there's a CLI that makes it easy to set up your application before launching. This is an example of how you set up the Amplify library. It's really simple. You import it, you configure it using the config, and then you run a query. This is just an example of how to use the AWS Amplify library when using AppSync and the API category, but there's actually many more that you can use, including storage, analytics, S3, including Dynamo, and authorization. In addition, I mentioned that we have context-specific wrappers for different frameworks. So here's an example of how you could use Amplify in addition to React and React Native to connect a component with data from your AppSync API. And it's really easy to use. Another important category for Amplify is Amplify codegen. This is also used when using AppSync and the Amplify library with GraphQL because it allows you to generate queries as well as native types from your GraphQL API that can be used directly from your iOS, Android, TypeScript, or Flow application. And then you'll have static typing in your native environment. And a lot more. So if you need to learn more, there's two documentation sites I'll point you to. There's awsamplify.github.io. That'll have all the new documentation for the AWS Amplify CLI. And then there's docs.aws.amazon.com/appsync. That will show you any information on AppSync specific to resolvers, data sources, and your schema. And you can find me on Twitter and GitHub at Mike Paris Stuff. So now I'm going to break out, and we're going to do a little bit of a demo. Okay, so I have a brand new directory here. You can see there's nothing. And what we're going to do is we're going to start from a small starter kit, and I'm going to talk through all the things I just showed you in slides. So this is the AWS Amplify GraphQL AWS sample. It's been recently retrofitted to work with the AWS Amplify CLI and GraphQL Transformer. And we're going to talk about how to set this up and talk about what's going on behind the scenes while we do it. So the first thing I'm going to do is I'm going to clone this repo into my new project. And as that's going, there we go. You can see that we just got some new code here on the left. And then as the README states, I'm going to go ahead and run a few Amplify commands that you can see right here. So first, I'm going to run Amplify init. Amplify init is going to create a project locally, the configuration locally, as well as deploy an initial CloudFormation stack into my AWS account that we can look at. So I'm just going to go with some of the defaults, which are set up to be pretty smart and work well with React out of the box since I chose React as my framework. And you'll also notice that I selected my code editor of choice. That'll come into play later. So as this is deploying, I'm also going to select a profile. A profile is essentially an AWS credential that you're setting up locally that the Amplify CLI will use to interact with AWS resources on your behalf. This allows you to specifically restrict access that Amplify has by adding policies to that credential. So as this is deploying, we can go ahead and pop over to CloudFormation and see that we're going to have a new stack. So the Amplify CLI under the hood uses CloudFormation and nested stacks in order to deploy all of its resources. There's a rough one-to-one mapping between a category and a stack in Amplify as of writing, but this will likely change in the future. So as soon as this is done, we'll be able to go ahead and start adding Amplify categories. So let's go ahead and jump back to the README to see what we're going to do. So right now we're running Amplify init. The next thing we're going to do is we're actually going to add Amplify auth, or Amplify add auth. What this is going to do is create the user pool that'll serve as our user directory in the application, and it'll give us user login, including authentication and authorization within AppSync. When we use a user pool, it makes it easy to do fine-grained authorization in AppSync, such that you can create policy or create authorization strategies, like we mentioned in the slideshow, where an owner would be able to access an object, but non-owners might not. So let's go ahead back and see. Okay, so that finished. So now I'm going to go ahead and do this again, and I'm going to do Amplify add auth. I'm going to go ahead and select the default configuration, which is set up to work pretty well for most use cases. I'm then going to go ahead and add storage, which is in this case going to be an S3 bucket. So you have a choice here between content, which will be an S3 bucket, or a NoSQL database, which will be a DynamoDB table. I'm going to go ahead and accept this. The bucket name is fine. I'm going to say both auth users and guest users should be able to access, and I'm going to give authenticated users read-write and guest users read access. So that's all good to go. And now, as our README said, the last step was to do Amplify add API. This is going to add our AppSync API to our deployment. So here I'm going to go ahead and select GraphQL. I'm okay with that name. I'm then going to select Amazon Cognito user pools. And it's asking me if I have an annotated schema. So this is, in this case I do. I actually have it open above, and you can see it in the root of our project directory. But I'm actually going to say no, so that we can see what this will do. It's next going to ask, do you want a guided schema creation? And I'm going to say yeah. And then it's going to ask, do I have a, is there a sample that'll best describe what I want? In this case, I'll do the single object with fields just to keep it simple. And then I'm going to say I do want to edit the schema. So if you remember back to when I first ran Amplify init, Amplify init asked me if I had a code editor of choice. When I registered that, it kept track, and then in this example where I asked it to edit the schema, it was actually able to open the schema for my project in my code editor automatically. It then said, press enter to continue after you edit the file in your editor, and it gives you a path. So this is a basic to-do model, but here I actually don't want this. I'm going to go ahead and rewrite this with one that we have already in this project. So if you look here at schema.graphql, this is the schema I'm going to use. So I'm going to copy it right over to my new project schema file. So what does this data model do? Let's talk about it for a second. So here you can see we have one object type called picture. This picture object type is a model type, which, as we said earlier, means that it's going to be stored in DynamoDB and it's going to have CRUD operations generated on its behalf. We also have added the @auth directive, which in this instance is allowing ownership authorization on this model type. By default, ownership authorization will automatically fill in the ownership credential into a field called owner. You can overwrite this using an attribute called the owner field, where you can change this, as we saw, to something like editors, if you wanted to have a list of owners, or some other field. We're going to leave it as a default, but just it's good to know that this is the field that's actually going to be storing our ownership credential. Next, you can see that we have this type S3 object. Type S3 object is actually kind of special in AppSync because the SDKs, the client SDKs, understand the S3 object and know how to upload and download files automatically. What this means is that in order to add S3 support to an application, all you need to do is add this type S3 object type definition to your schema and then reference it from some field in an object type within your API. This visibility enum is just a good example of some other advanced things you can do in GraphQL where you can define types that will implement enums, and the type system will be respected once you start interacting with your API. So this is a pretty simple model, and I'm going to go ahead and just click Save, and then I'm going to go back to my terminal, and I'm just going to click Enter. So once I ran that, you'll see that it has successfully compiled the GraphQL schema. You can edit your schema again at this directory in the backend folder of our project. And now we're ready to deploy. But before we deploy, let's look at what this just did. And I want to make one important note here that now our schema file is in this backend directory. So if you go to Amplify, backend, API, the name of your API, and then schema, this is your project schema file where you can edit this, and then all changes that you make to this schema will be pushed to AWS as soon as you run Amplify run push or Amplify push. That also means that this schema file down here is no longer needed. This is here just for distributing the sample, and I'm actually just going to delete it to avoid confusion. Cool. Okay, so now you saw that our GraphQL schema was compiled successfully. Where did that go? So if you go back to this backend API directory, the webinar demo, and you run, well, first I'll run push, and that's going to deploy our project to the cloud. And then we'll look at what this actually deployed. So this simple schema.graphql file was our input document. This is where we define our directives and our authorization directives, our authorization rules, and the shape of our data. When this is compiled, it actually becomes a much bigger schema file. So this is the compiled output of our GraphQL input. And you can see all the extra boilerplate that's in place that we didn't have to write. In this example, you can see that there's a type mutation where there's create picture, update picture, delete picture. There's subscriptions that you can subscribe to the particular mutations on the subscription type. There's also queries for get and list. And then there's these cool model filter inputs that we can see later and how those work that allow you to really express more when you're querying data in your API. So since I ran push, this is going to compile and deploy this CloudFormation document. Here's the CloudFormation document that it's going to deploy for the API. Again, you can see all of the code that we didn't have to write. There's a GraphQL API record, there's an API key, there's a picture table in DynamoDB that's configured to work with our data model. There's IAM roles that are stripped down to give the minimal access that we need on your behalf, and much more. And that all came from this simple schema file. So this is now deploying. As soon as it will. And while that's deploying, I'll take the time to show you guys some documentation. So here's the Amplify docs. The Amplify docs have all of the information on the GraphQL Transform and the Amplify CLI, as well as the Amplify library. The best place to start is just going to docs, and then the JavaScript docs are an easy place to start. Here you can see a quick start, as well as full documentation on the GraphQL Transform. These documentations outline all of the directives that we have access to. For example, you can see our app model, and you can see the full definition of the app model directive, as well as different examples of how to use it. You can see the same for auth, which has multiple strategies, including the ownership authorization, group, dynamic group, static group, and multiple ownership. There's then connection, which we mentioned is a way to create explicit relationships between object types in an API. There's a version connection directive that allows you to add object versioning with conflict resolution and conflict detection automatically, as well as a searchable directive that allows you to automatically stream information from DynamoDB into Elasticsearch using DynamoDB streams and AWS Lambda. Okay. So this is slow. Okay. This is just taking a minute for this to deploy. While this is going, we'll also go ahead and run an npm install to get our local client dependencies. Oh. Looks like this might have frozen. Let's try this one more time. Okay. There we go. There we are. Okay, now it's deploying. So now we have our dependencies installing and our API is deploying, and we can go look at that in CloudFormation. And you can see what's going on is we now have multiple stacks that are being deployed. Like I mentioned, when you do Amplify init, it will actually create one parent stack that'll serve as the entry point for all of the other resources in your AWS account. And then as you add categories, often those categories will result in adding their own child stack to the overall nested stack of the application. So in this example now, you can see we have our parent, but then we also have a stack for our authorization and a stack for our storage, which will both be getting spun up. While that's deploying, we can also take a look at the code in this project so that you can get an idea for what's going to be going on. So this application is a good starter project for projects that need users, that need authorization by user, and that need to be able to store files in S3. And you can see that the process of setting this all up is actually very simple. What we're going to do is we're going to import our AWS config like we saw on the slides. We're going to import Amplify, and then we're going to configure Amplify. This one command will configure all of the Amplify categories, and you don't have to do anything else. What we've also done here is we're using the AWS App Sync client and the AWS App Sync SDK in order to add data to our React application. When you're using that, there's another step you have to take where you're just going to instantiate the client using the same information that comes from your AWS config. And then here we're doing two important things. This auth is allowing us to authenticate against our GraphQL API. This is using a user pool credential that's automatically being handled by Amplify's auth category. Next, you're going to see that we have this complex objects credential. This is a different credential that allows our client application to upload files and read files directly from S3. When we did Amplify init actually handled creating not only our user pool, but also an authorized and unauthorized role in our AWS identity pool that allows us to request information from S3 in addition to our AppSync API. Once you've created the AppSync client, you're just going to feed that client into an Apollo provider with this rehydrated component that'll make this application work offline out of the box. Once you have this simple setup where you've instantiated the client and provided the client to your AppSync provider, all you need to do next is write components. So we have a simple component here called add photo, where add photo uses an HTML input element to select a file from your local file system. And then it runs a mutation, the create picture mutation, which you can see here, to add a photo to our application. Put these side by side. So here, what you can see is we're using the GraphQL higher order component in addition to the mutation create picture mutation to add a mutation to this component. What you're also seeing here is the logic that implements optimistic updates and offline support in our application. So this option attribute and this update function are what will be called once the mutation has succeeded, as well as before the mutation has succeeded and right after mutation has been called, giving you an opportunity to do an optimistic update. And you can take the data from the mutation and then merge it into your local cache wherever you need. This is a common pattern when writing applications with GraphQL, where you'll have Some offline cache, you'll be able to read a query against that offline cache, in this case, the query list pictures. And then you can use the results of the mutation and automatically merge that data in before writing the query back to the cache. Here you can see the optimistic response, where the create picture mutation, when invoked, will call the mutation. It'll provide the photo as the input to the mutation text, as you can see here. And then in the optimistic response, it gives us an opportunity to create an object as soon as the mutation has been invoked, but before it responds to keep our UI quick and snappy and immediately show this update to the user, which we'll see as soon as this finishes deploying. So that's the add photo component. You can see it's fairly simple. It's just forms and HTML inputs. And then what you'll see here in the handle submit is that we're actually never doing a file upload. The file is uploaded transparently by the AppSync SDK. So here you can see, if selected file, we're going to add this local URI attribute to our file input, which points to the actual file object in our browser. Because the AppSync SDK understands that S3 object, like we said here, it understands to look for this and correspondingly can look for the S3 object input, and then is able to get the file using this local URI attribute and will automatically upload it to the location in S3 designated by the bucket key and region in the file input as well. From there, you can just call this.props.createPicture, pass it the name, the owner, the visibility, and the file, which has the local URI. And this will be transparently updated and added to S3 without you having to do any explicit calls to S3, and will be authenticated using the unauth and the authorization roles that were created when you initted the Amplify project. You can also see the all photos component that, similarly to the add photo component, will be connected with a query, but in this case it's much simpler. We've got our query with our list pictures. It's got a refetch policy that says both use the cache and the network. What that means is if it's available in the cache, it'll surface that information immediately, and then it'll also make the network call, which will update the cache after viewing it the first time. And here you can see I'm just passing my photos from the list pictures result to the photos prop, where I can then do props.photos to get the information that I wanted for my query. So now that this is deployed and our project has stopped installing, I'm going to go ahead and just run. And we're going to be able to see our application. One last thing to show before we dive into the browser is to just make note of this with authenticator component. This is a really neat thing that comes out of the Amplify library that gives us a UI component to automatically implement authorization with user sign up and user sign in using Cognito user pools. So as this comes online, wait just a minute. Let me make sure. Okay. As that's going, let's go ahead and poke around the AppSync console. And here you can see our API. So as we're waiting for our development server to start up, you can see that we now have a full API, and here we can poke around and see what's going on. So here's our schema. This looks similar to the output. It's the same as the output that I showed you in the code editor earlier. You can also see that we have a new data source, which is pointing to a DynamoDB table. And we also have a number of resolvers in our schema, which you can see as we scroll down. So for example, here's the create picture resolver. If you remember, create picture was protected with ownership authorization rules. So you can see here in the resolver code that there have been snippets added to our resolver to implement the owner authorization check that are then used down below to protect this operation. You can see that it's a put item operation, and we didn't have to write any of this. This was all generated using the Amplify CLI and the GraphQL Transformer. You can also go ahead and look at the DynamoDB table that we created. This was also created because we had the app model declaration on the object type, and you can see we have no objects yet, which makes sense. This is taking... So while we're here, I'll go ahead and show you how you can use the AppSync console to test your API. So if you go to the spec CloudFormation and you look for the API stack, which is right here, if you go to the outputs, you'll see that it outputs a Cognito user pool JS client ID. In this case, it was created by the Amplify CLI, so it's telling us to go look at that user pool. If we look back to the auth stack in the outputs, it will have the client ID for the web. And we're going to go ahead and copy that. Then we can go back to the AppSync console, use that client ID, and then we're going to be able to create a user as soon as this starts up, which it has. So going to our website, here you can see we're on port 3000, and the first thing we see is this beautiful little login component that comes out of Amplify. We don't have any users yet, so I'm going to go ahead and create an account, add a password, add an email, and that's it. Now I'm going to wait for that. And then let me go ahead and get that email. Let's see. Try that again. There we go. And I just got a email 10499. And I'm going to go ahead and sign in. And here we are to the application. Next, just to test this is all working correctly, adding a file. We're going to browse our files, grab our logo, open, click add, which is going to call the add photo component, which then you could see the optimistic update happen for a second, and then we added our file, and I can subsequently download this file from S3. We can do it one more time to test. And add the photo. Now to prove that, we can go to our DynamoDB table, refresh it, where we see that there's two new records. There's a type name of picture, I've created that, and then there's a pointer to where they are in the bucket, as well as the visibility, the owner, and the name. in the file. We can also go here and log in. So now I'm going to run that same query to list my pictures for my user. That's great. So there you can see that we just deployed an application that implements a data model for our application without having to think about the underlying infrastructure. We can also do some more complex things out of the box. Since now we have list pictures, we can even try adding a filter where I can say, I want only the pictures where the visibility is private, or where the, let's see what's going, the owner, you can even see the owner, and then the name. Here you can see the owner is automatically filled in as Michael, and we can ask for all files where the name is equal to adding a file. Since we have this filter object, AppSync automatically handles converting this into the DynamoDB filter expression so that we can have a nice and easy to use interface from our client. And that's great. So then the next thing that we want to do is figure out how to expand this. Since we're running out of time, I'm just going to show it quickly, but what we'll do here is a connection. So I'm going to go ahead and add a presentation type. We're going to add the same rules that we had before, such that only owners can update it. And then what I'm going to do is give it a name, and we're going to create a connection between pictures and presentations. So here I'm going to say a presentation can have multiple pictures, and we're going to give it a name of presentation pictures, and I'm going to say that a picture can have a single presentation. And we're going to leave the name the same. This name is going to be used to configure the GSI that enables this connection. So now I'm going to go ahead and just run API GQL compile to make sure that my API is correct. And then once I've done that, I'm going to go ahead and run Amplify push again. You can see that it detects that our API has a change. I'm going to say yes, and we're going to go ahead and deploy. So now let's go back to CloudFormation and we can take a look at what that's doing. So as that's deploying, we're going to see that it's going to impact two of our stacks. First, the parent stack. This is the entry point for any update. And then next, since it only updated the API category, you can see that it's going to start updating that next. You can watch the events as it happens to get an idea for what's going on. First, it's going to deploy our GraphQL schema. And then after that, it's going to start updating all of our resolvers with our new logic. You can see as that happens. And then as soon as it's done, we're going to have a whole new set of functionality in our API. So while we're waiting, we can go look at the schema in our AppSync console. And you can see now that not only are there pictures, but there are presentations. We'll wait just another minute for this to finish. You can see it's updated our picture table. We can look at that to see why, and the reason is that it's actually added a new index for us, or will be adding a new index. Oh, wrong. On the picture table. You can see here it is. It's being created. This GSI is what's going to allow us to get all of the pictures for a single presentation efficiently. I'll refresh this one more time. You can see this is just about finished up. It's updated. So now since it's updated, I'm going to hop back to the AppSync console, and I'm going to refresh. And then we're just going to run a quick set of queries to show that this connection did what we wanted it to do. And first thing we're going to do is go to queries. We're logged in as Michael still. And down here, I'm going to run a create presentation. Cool. It's got a name. And then I'm going to get its ID and its name back. So we created the presentation. I'm now going to go ahead and create a picture. And what you're going to see, picture, is that we have a new field in here called Picture Presentation ID, where I'm going to provide it back my presentation ID, and then I'm going to get the picture back. And here you can see I'm actually going to be able to get the presentation as well. So I'll create the picture, and here you can see I got the picture, and I also got the presentation that it belongs to. I can then go ahead and prove that I can get the presentation with that ID. And then I'm going to get all of the pictures for that presentation with a single query. And there we are. So you can see with just those few lines of GraphQL, we were able to define this relationship between presentation and pictures. We were able to deploy it to the cloud, which automatically implemented the GSI necessary to make that work. And you can see that now we've got all of our resolver logic, all of our resolver code is also written for us such that we can get the picture off of the presentation and the presentations off of the picture using efficient DynamoDB query operations. Okay, guys. Thanks for chiming into the webinar. Really hope you guys got something useful out of it. Hope this showed some of the cool things you can do with the new Amplify CLI and how you can evolve your applications using just this simple GraphQL configuration and then kind of consume that from different web and mobile applications. I only showed React, but you can do the same thing for iOS and Android. And if you have any questions or feature requests, please reach out to us on GitHub, on the AWS forum, and via any of our other interaction channels. Thanks, guys.